Welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board, and today's topic is experimental methods. So suppose you have the question is, do people tell more jokes after, let's say, after 2 drinks? After 2 alcoholic drinks. So you have a control group that's given no alcohol, and a treatment group, let's say, is given 2 alcoholic drinks. And the question is, who tells more jokes? Now, a problem with that is that suppose that the people who have gotten the alcoholic drinks, and let's say they know they've gotten the alcoholic drinks, may just think that they're expected to tell more jokes and therefore tell more jokes. So anytime, and this is called the placebo effect. For example, it could be that if you offered 2 non-alcoholic drinks to people, things that they thought maybe were alcoholic but weren't really, you would get the same effect as giving them 2 alcoholic drinks. So that's the placebo effect. When the subject of the experiment reacts to the thought that they are being treated, or to the knowledge that they are being treated. And one way to deal with that is to do a blind experiment in which the subject does not know whether they have gotten the treatment. So it involves a little bit of deception, actually, but not knowing whether they've gotten the treatment. So you would give, in the drinks example, you'd give the treatment group and the control group something that tastes alcoholic to them, and not tell them whether they've gotten the pseudo-alcoholic or the real alcoholic drinks, and then observe how many jokes they tell. Now, suppose you had another problem, which is that the measurement is subjective. So suppose we had a subjective measurement, and it could be that how many jokes you tell is somewhat of a subjective measure. So a subjective measure by an observer. So we're going to have an outside observer who's going to say whether people told more jokes or not. If the observer knows which group had the alcoholic drinks and which one didn't, and the observer expects the alcoholic drinkers to tell more jokes, then the observer may give a biased report. So to deal with that, you create a double-blind experiment where the observer does not know who got the treatment. Okay, and that eliminates the observer bias. Now somebody has to know who had the treatment. So the investigator, we'll call it the investigator, or the head researcher, knows who got the treatment, otherwise you can't do any meaningful measurement. But the observer who's doing the measurement does not know who got the treatment. That is a double-blind experiment. Okay, so that explains blind and double-blind. And now I want to go into a topic that can be a challenge. It's called blocking. And the idea there is to take, in some sense, stratified samples when you assign treatment and control, because you're worried about that the lurking variables might not turn out to be random, but you know what's going to affect something. So let's say we were going to measure the effect on muscle mass of a conditioning program. Okay, so let's say you have let's say that you have 20 subjects available, and 12 are men and 8 are women. If you just randomly assign, let's write that a little more clearly, 12 men, 8 women. If you randomly assign them to the two groups, let's say so you're going to have two groups of 10 get the program, 10 don't get the program. And if you just randomly assign, it could turn out that you have, let's say, 8 men and 2 women here, and 4 men, remember, because there are a total of 12 men, and 6 women here. Again, you wouldn't intend to do this, but if you just did a random assignment, you could get this. And having this, the treatment group be dominated by men, would produce messy results. That could be what dominates your results. So what you'd like to do is make sure that you put 6 of the men in the treatment group, leave 6 of the men in the non-treatment group, in the control group, and then you split the women up that way. So what you do is you randomly assign the men, 1 to each, 6 to each group, and then you randomly assign the women. You don't group them together and then randomly assign. So that would be called blocking by gender. Okay, so that's so what you're doing is you're creating blocks. So instead of looking at this sample and saying, well, we've got 20 people and we'll just start with that and assign them, we'll divide them into 2 blocks. We'll divide them into a block of 12 men and 8 women, and those are our 2 blocks, and then we will randomly assign within those blocks. So that's blocking, and I think I'll finish up with that. Actually, let me add one thing, which is that if you don't block, you don't have a biased experiment. Your experiment is still unbiased. It's just that you're creating an additional source of variability to the results. So blocking reduces the variability of the results due to this lurking variable gender. But even if you didn't do any blocking, as long as you did pure random sampling, it would still be unbiased, but you're just creating more variability. So blocking reduces variability. It does not address bias.